Hi, it's 21st May, and today I went about this Chroma DB thing and the project which I was doing, and I was here uh, on the last time I had an LLM working for me to find the relevant context from this vector DB. So what I was going to do is take this query, do a dot product with all these vectors, find the relevant context, and bring it to this LLM. This LLM then makes the decides what is the information which should be passed as a relevant context to this thing. So after that we have the full query, and after that this LLM ingests this full query and gives this JSON output. This was the architecture I was working on, and after that what I did was, let me show you the code instead of just yapping. So the very first thing that I'm doing here is getting the project directory and making a few folders. Actually this one is vestigial, I don't want that, so I'll remove that from the code right now. So you need that, yeah. So this is the required fields that we want. So basically what is happening is, let me show you my file structure here. So I have these a lot of documents. These are all job descriptions about various companies, because I was looking for a job this year, and so I collected this as data, because they are farming our data. Why won't we farm their data? So what I did from this, I took all these documents and converted it to computer readable and computer semantically understandable markdown text. The markdown text is then stored here. So these are the documents which have been processed till now. Now bear in mind that all of these conversions from PDF to markdown are pretty expensive in terms of time. So it takes a lot of time when it converts all of these things. So I mean, it can be done quickly. There are a few cloud solutions as well, but then they cost money, and so there are only two options. Either we scale up the CPU and GPU, and it does OCR just like that, which would require a GPU. I mean, a modestly 4 gigs of GPU or VRAM would also work really nicely in this case, because all we are doing is just OCR right now. That's all the that's the basically the bottleneck here. And these are the questions I'm asking from each PDF. This is a really unstructured data. Let me show you one of the documents. So this is a document. This is a Sunshore job description. It has these all of these descriptions about the company, their history, their revenue, and I mean, of course, we don't want the revenue at the very first confrontation, when we want to select which role, and we want to collate what do we want to pursue. We don't want really this kitne crore ka loan project they did or whatever. We want the role and how, what do we have to do here, what's our role in it. So what I did was I asked a few questions from it, the name of the company which is organizing the competition, and the amount of experience which is required, and a list of skills. I mean, from this thing, a list of skills which are required for this job, name of the role the organization is hiring for, overall description of the role the organization is hiring for. So so this is basically all the questions that I'm going to ask. This is sorted out in a structured manner so that it can understand this, and this is basically end comment. And after that I'm giving all of these things to get field values. What it does is, let me show you what it does here. It goes through every single directory, every single PDF file or a doc file, or in future I'm going to make it Excel compatible as well, so I'll add that later. But right now I'm doing this to have compatibility with PDF files. So for every PDF file I'm going to get the file root, get the expected file. If the markdown is already processed, it won't be processed again and again. I'll just say markdown made, and after that I'm going to upload all of this markdown to a vector database. So what it does is, in vector uploading I am making all the chunks of the data, and after that I am sending it there. Let me show you this. So what happens is, I'm taking for each chunk in enumerate chunks. I'm using this chunk text function, which has been useful from this. Let me show you where I got this from. Yeah, so this is the chunk text function. Right now the chunk size is 500 characters, so this makes a chunk, and after that all the entire chunk gets a document id, and the entire document with along with the document id goes into the vector collection. And inside the vector collection, we have these all these vectors uh, for different chunks. So each chunk has a different vector, and whenever query passes through this vector database, it collects n first queries. So right now my default value is 4, so it picks up 4 chunks from it, and after that it gives it to the LLM, which has to decide that what context do I have to keep, and what is just garbage value. So what happens is we don't need that much context size in the LLM, and we can just run it locally, and it will give really magnificent results. So yeah, so after that what I'm going to do is you know after the entire thing is uploaded, we do a query so that the LLM compares what is relevant and what is not. And after that we do a rack query on the second LLM, which is locally running, and it's a generative uh, transformer. This isn't exactly a generative transformer, this is a classification. This is more of a classification transformer. And this one, actually there are three transformers used here. So the first transformer is used in OCR. It's a VIT transformer. It's a vision encoder decoder architecture. You know, so that's interesting. And now, so that's exactly why this is a pretty costly process in terms of compute power. And after that we are using this rack query. We have the all the relevant context which with the real juice of the entire PDF file which I showed here, and this goes through this thing, and after that we remove the thing tags, and it makes the JSON string and it saves to the JSON file. So let me show you an example. So this is the PDF file, the company name is Sunshore, and we know like this is the job title. I mean, this one is pretty easy because they have given it quite explicitly, so it won't be that good of an example, but let me just show you anyway. So I think this is the one. Yeah, so this is the organization, the experience it doesn't mention. Let's see if experience is even mentioned here. Yeah, so experience is exactly not mentioned here in terms of years, because like some it's for freshers, right? It's a graduate engineering trainee. So what I should do is, I should also do a query for what is the degree required, minimum degree required. It will give me that these things in these disciplines, which degrees are eligible. Let me just put that as a note here. Yeah, so after that we have these role and role description. A role requiring coordination with internal and external parties. Was it even mentioned here? Internal. Yeah, it just paraphrased the entire thing. And ability to prioritize tasks, stuff like that here. And focus on reliability and these are the things. So it basically boils down a lot of things into very succinctly phrased descriptions. And so basically we have this the organization name is all right, and let me show you the original PDF from which it came from. So yeah, work days is 5 years of experience, just set 0. That's cool. And employment time is full time. We don't need that as a job, of course, it's full time. And sales and marketing associate, that's also quite nice. So yeah, I mean it works in OCR, and it works in text form as well, because in Sunshore the name of the company was in this image format, and it OCR'd the entire thing, and that's how we got to know that this is Sunshore. And right now what's happening is we are converting each of these things into these JSON files, and right now this one is being processed PM trainee MD chunk. So let me show you what this PM trainee is. So this is the PM trainee MD chunk here, which I'm talking about here, and I think the markdown for it is already made. Let me show you the markdown real quick. This is the markdown. Yeah. So we have the company name, that's cool, and the functional area. Let me show you the image from job description, right? So yeah, that's that's right, and that answer can be made quite easily from the rack pipeline, and job role is also there. So I mean, it's a pretty text heavy document, so that would also be pretty easy for it to process. Let's see what happens here. It's in the DB now. Let's let it run for quite well. Let's see. So that's completed. It did this JSON in it took some time for the query to run, because again this is an Olama model and this is running on local. So these are only 4 billion parameters, but still it's quite a huge thing to go through for all this huge neural network. So this does it. I think this is the entire structure for right now, and if we want to if we want to do a global search from the all of the documents and find out the relevant information, just by name, like getting the, if you want to query this name, what could happen is we could you know we could avoid just deleting the entire collection when we are trying to insert a new document altogether. So we have all these vectors embedded inside already. So it's just caged. Basically what I'm saying is everything is just caged inside this one huge collection, and then we can do this querying just by doing the same old rag what we have already been doing for all this while. I think this would be the line which we have to just delete if we want to do the entire global search, because we are cleaning the collection every time we are trying to add a new file. So this is it for today. I think I'll try to make it more compatible with other use cases and add Excel files also, and try it on the train test dataset. This is basically, I mean, this is just a experiment thing, because it isn't exactly solving a real problem. Let's solve a real problem after that. And I think the pipeline is pretty good. It's pretty robust right now, and I think it's ready to rock. I'll stress test it more tomorrow, and let's see what happens.